Hi everyone, I'm Siad Manim from Soma Academy, and today I'm going to show you how to find the derivatives of functions using the power rule. Before we get started, I want to ask you guys to subscribe to this channel. That way, when I release new content, you will get notified. Let us start with the definition of the derivative of a function. The derivative of a function, say y is equal to f of x, of a variable of x, is the measure of the rate at which the value y of the function changes with respect to the changes of the variable x. Normally, the derivative is just another word for the slope of a function or the tangent of a function. It's also called derivative of f with respect to the variable x. It's also called the derivative of f with respect to x. This will all make sense when we do an example. However, today I only want to focus on one of the rules of derivative. Derivatives have so many rules based on the different functions that you are given, but for this lesson today, I will only focus on the power rule. The power rule, when finding the derivative of a function, is such that if, for example, you have y, which is equal to f of x, is equal to x to the power of n. If you have this function, x to the power of n, and you want to find the derivative of this function, you have to use the power rule. What the power rule states is, you take the power, you drop the power and put it in front of the variable x as a coefficient and reduce the power by 1. Let me write that down. So you bring n down, because that's the power, multiply it with the variable x, and reduce the power by 1. So it was n, you reduce it by 1. So generally, this is the definition of the power rule. Let us do an example. Assume you are given the function f of x is equal to x to the power of 5. And you want to find the derivative of this function. The way we denote when you are finding derivative is you use f prime of x. This is to show that you are finding the derivative. Is equal to, bring the power down, 5 multiplied by x, reduce the power by 1, which is 5 minus 1. So this will give me 5x, 5 minus 1 is 4. So that is the derivative of this function. Let's do another example. Say you have another function f of x is equal to 3x to the power of 6. In order to find the derivative, we said we denote it as f prime of x, or you could write it dx. That's another way also of writing f prime. Okay, this is the same. So this will be equal to, bring the power down, 3 is already the coefficient that was there, multiplied by 6, which is the power, multiplied by x, and then reduce the power by 1, 6 minus 1. So this will give me 3 times 6 is 18, x to the power of 5. Let us do some more examples to make it more clear. You have the function f of x is equal to x to the power of 10. In order to find the derivative f prime of x, this is equal to, bring the power down, 10x, reduce the power by 1. This will give me 10x to the power of 9. Okay? Sometimes it is possible that you are told to evaluate the derivative function, the derivative of the function you found at a given point. Say, for example, you are told evaluate f prime of x at 2. What this means, you have to substitute, wherever you have x, you have to substitute with 2. So this will give me 10x to the power of 9, but instead of x, you have to replace that with 2. So this will be x 10 times 2 to the power of 9. So what is 2 to the power of 9? You can use your calculator to find that and then multiply. That will give me 10 times 2 to the power of 9. Okay? So it's possible that you are asked to evaluate f prime at a given value of x. If it was 1, if we were told to evaluate at 1, we would just put 1 here. 1 to the power of 9 is just 1 times 10. So that in that case, it will be just 10. Because any number, 1 to the power of any number, a million, a 10, whatever it is always 1. Okay? Let us do another example. You have a function f of x is equal to x to the power of 3 over 2 plus 3x. So in order to find f prime, you have to take the derivative of this function and also take the derivative of the next function, and then you add. Okay? So the rule is the same. Bring the power down, 3 over 2 x to the power of 3 over 2 minus 1 plus 3. In this case, x is to the power of 1. If you write it just x or x to the power of 1, it is the same. So when you bring the power down, it is 1 times 3 times x. But you reduce the power by 1. So 1 minus 1 is 0. X to the power of 0 is equal to 1. Any number to the power of 0 is 1. That is the rule. Any number to the power of 0 is always 1. So the whole of this just becomes 3. In general, if the power of the x term is 1, you will always have the constant as the derivative. If you had to take the derivative of 4x, the derivative will be 4. If you had to take the derivative of 10x, the derivative will be 10. So always you will have the constant as long as the power is 1. But how about this case? When you reduce 3 over 2 by 1, what do you get? So you have to find common denominator. 3 over 2 times x. The common denominator is 2. 3 minus 2, that is a half. Okay, so plus 3. So here you will have 3 over 2 x to the power of a half plus 3. That is your final answer for this derivative problem. Okay, let us do one more example. Say you have the function f of x is equal to x to the power of 3 plus 2x to the power of 2 plus 2x plus 6. So in order to find the derivative of this function, we have to take the derivative of each term separately and then add all of them together. What is the rule? The rule is bring the 3 down, multiplied by x, reduce the power by 1. 3 minus 1 is 2. Here you have 2. Bring the other 2 down, that is the power, times 2. X to the power of 2 minus 1 is 1. You can You can write, or you don't, if you want, you don't need to write that. Okay, so x, 2x, what is the derivative of 2x? In the earlier example, I said if you are taking the derivative of a term where the variable x has a power of 1, which in this case the power here is 1, you will always have the constant as the derivative, because the reason is you have 1. When you multiply 1 by 2, it just gives you 2, but if you reduce the power by 1, it becomes x to the power of 0, and I said x to the power of 0 is 1. Why? Because any number to the power of 0 is 1. Okay, so the next term that is left is a constant, 6. The derivative, this is a rule, the derivative of any constant is always equal to 0. So you have to remember these two. 6 is a constant because it doesn't have the term x. It's always equal to 0. So in conclusion, what is our final answer? 3x to the power of 2 plus 2 times 2, 4. 4x, I don't need to write that one, plus 2. So this is my final answer. For today, I will stop it there. Thank you for watching. Please do not forget to subscribe. Until then, happy learning.